Well, there's the cement mixer, big bad boy motor. It's good size. We're just going to start opening some things up, and then we'll do some checks. Ooh. Spiders got in there, but other than that, it doesn't look too bad. Before I do much more here, I have to figure out which leads are what. It was wired for 110. Alright, we disconnected the wires, and they were hooked up with these three and these three. They've been stamped on the end of the lugs of which number they are, and they correspond to the numbers on this nameplate or data plate. And they were hooked up as a clockwise rotation, low voltage connection. And we took some measurements on everything, and I measured it to ground. So only one lead, and number 8 is to ground, and none of the rest are. And I made a little diagram of what I measured, and there's nothing going on in this lead here. So I'm assuming there's the centrifugal switch in this motor. What I did is I looked up inside in the back here, which is heavy and hard to do, and it's full of, there's grease, there's spider webs, there's a ton of junk in there, and it looks like there is a centrifugal switch to cut out the starting winding. So we're going to pull this end bell off, and we're going to take a look at that. Now this is a ground off chisel. It's nice and rounded here, and they've got some tangs. These are castings. I'm going to do these screws on the end. Oh boy. Nice little mess in there, huh? There's the capacitor right there. That's where the capacitor is. And these wires don't look in very good shape at all, since there's no insulation on there. So we could replace those wires, that's for sure. Get the capacitor out, and we'll get all this cleaned up before that goes back on, that's for sure. Spiders and grease and everything in there. Now this is the centrifugal switch and a bearing housing, and I'm going to, oh there, that's going to come off nice. We're just going to pop this off so we can get this apart and cleaned up. There's ball bearings in the motor. I'm using a proto wheel puller. There we go, that came right off. I don't know if you can see here now, these are the weights, these little pieces of bar looking stock. It's just sheet metal formed, and they throw out, and then the switch releases as a motor when it comes up to speed. Starts, and then this will throw out and disconnects the starting winding, and it's like that. And the capacitor, I'm sorry, starting winding and the starting capacitor get disconnected. goes. All right, I've cleaned up the centrifugal switch. Took it apart, which is only a few pieces. There's a very tiny spring in here. It's hard to show putting it back together and all that. I put a new band on. This was really completely missing, this conductor. And fortunately I had some of this kind of stuff, this braided wire for easy flexing, so that allows it to flex easily. And how it works is that's the action of it. I cleaned up the contact surfaces. Anyway, so that's the action. I put in a new wire for this piece here that will come out to the connection box. And then the capacitor will be hooked onto here. So that's the switch all cleaned up, ready to roll. Here I put a lead on there to hook to the capacitor. And then we've got little anti-seize on these little bolts. There we go. Looks pretty good. That should function just beautiful. Versus not functioning. Alright, this is the other end. I got it loose. I got all the pulley off. And they had this thing on here. I don't know what it was. This was like, it's not a nut. I don't know what it is. It's smooth. It was on there. I don't know. If it held the key or something. I don't know. There was nothing here on the threads to squish it tight. I pulled it off. Anyway, let's pull this out. It's pretty goopy. Pretty bad. A lot of old grease in there. Oh, full of old grease in here. So we're going to pull this all apart here and get this all cleaned up too. That's pretty dirty. All the old grease. All the old grease just oozing out of there. Oh man. What a mess, huh? Alright, I've gotten everything cleaned up. And I removed, of course, both bearings from the rotor and cleaned it all up. I cleaned up the centrifugal switch. I did not remove it. I just cleaned it up real good, and so it works very nice and very smooth now. So that's going to be fine. And now I'm putting the shaft end, drive end of the shaft back together, and we're going to knock this on here. This came off relatively easy. I did use a puller to pull the whole thing off. But putting a bearing back on, make sure you're on the inner race. Do not drive on the outer race ever. And it's nice to be able to use a press with this. I probably should be using a press, but it's going to go on not too hard. So I have a really nice tube that fits right over this, right over the shaft, and right onto the inner bearing race. And I'm just going to tap this on down. There we go. That went on really, fairly easy, and it should just, and this will slide right on there. Real nice. Just a real perfect fit. Now I completely washed out these bearings and re-greased them. They feel pretty good. I've written down the numbers, and when I know the motor works, I will see how it sounds and stuff, and then I'll decide if I'm going to replace the bearings or not. I want to make sure this motor is going to work. That was the bearing housing and centrifugal switch end of it. Now I've rewired this. I'm using the same capacitor that right here that was in there. It's not leaking and it's not shorted. So it seems to be okay. We'll see how it goes. I don't know what size it is. So we're going to test it out. I want to make sure this motor works before I decide to change that if I have to. And the switch is all ready to go, cleaned up, new wires on it, and functions. This is the switch activation plate right here, so when the flyweights come out, it will push on here and activate the switch. And we'll just put this on the same way. as the other one. There we go, that's knocked on tight. We'll slip this back in here. Now I've cleaned up this stator pretty good. I was tempted to actually wash it, but it's not too bad, so I just left it. I mean, I cleaned up all the loose grease and all that good stuff, though. Get this kind of centered up. I'm going to bend these wires a little bit. There we go. That's where it's about going to sit. These are dirt shields inside the end bells of the motor, and they're in pretty tough shape, so I had to clean them up and put some paint on them. We have our wires kind of tie wrapped together a bit. We have our capacitor in place with its little holder keeper down in here, and we have this pretty much positioned. What I'm going to do is I'm going to reach in here and get these aligned first and get the bearing housing straightened up. Then we'll attach it here to the frame. Here's the other end bell, dust cover. Looks good. Ready to go there. I'll slip this on. I'll just set it here and then align everything. Oh, that part is a success. Now we'll wire it up and we'll test it. This is here, I'll turn around. What this here is a hand crank megger. And this is a pretty nice megger. Actually, it can do just ohms. This can do 250 volt, 500 volts, and 1000 volts. And it also has a discharge position. And it's primarily used for reading mega ohms. You're measuring the insulation resistance. How strong is the insulation? How well does it resist the voltage to go to ground? Now, in most cases, I usually use 500 volts. If I was working on a system that the motor was 440 volt motor, let's say 3-phase motor, I would probably use 1000 volts then. You want to use more than what is normally applied, and I would prefer to use about 2 times as much in most cases. So 500 volts, this is a 240 volt maximum motor, so we use 500 volts to read measure the resistance. So I have this lead here connected to ground of the frame of the motor, and we'll test it, and I'll just hold this against another screw or some other part of the frame just to make sure we're hooked up. I'll hook that other lead on, and we'll give it a quick crank, and it goes to 0. So that means I have a good continuity on my connection to frame. And then we'll just do every lead independently of one another. And I'm reading at 500 volts, I'm reading approximately 750 megs. That's just fine. That's great. 10 would even be acceptable here, but you want it as high as you can get it. And that's about the same. We'll just do every one, and they're all reading the same. So we're good to go. As far as that goes, that tells me that when I put power to it, I'm probably not going to have a short to ground, which we don't want. Now I've measured all the coil windings already, and none of them are shorted. So the 2 run windings and the start winding, none of them are shorted. So we are good to wire this up. All right, we got temporary wire, just a quick tape job for temporary, and everything's free to not touch and things like that. So here we go. First plug in. Let's see if there's any arcs and sparks. Oh yeah! Starts right up. Pretty quiet. I hear noise on this end. It's probably the switch rattling. It's a rattly kind of noise. So, but other than that, smooth as can be. Turning in clockwise direction, and that's how the rotation. That's how I wired it for clockwise, and that's what it turned. So everything's good. Alright, I have a amp meter hooked up, and it's drawing 7.7 amps. And full load amps is 12.6 for 115, 120 volts. Well, I think that's a great success. I'll get this wired up, finish wire it, get the cover back on it. I still have a pulley to put on, and then we'll get the pulley on there. All right, motor's I would say complete. I opted to put brand new bearings in it, so that's done. And I used shielded bearings this time, so you're not having to pump a bunch of grease in and have it flow out. For amount that gets used, these should just work out just fine. And they're in an enclosure even, so they should be just fine. And we don't have the grease problems oozing out everywhere. It's all painted. Came out really, really good. And I have a pigtail wired in that will be used to go to the switch. And we're just going to turn it on. And we have the pulley on. Even saved the original GE logo cap on there and the name plates. So that's a pretty good looking motor. Let's plug her in. Starts right up, real sharp, quiet as can be, smooth. I think the motor's a completion, and we'll move on to the next part of the cement mixer.